Okay, so now that those three people have what they want, let's move forward. Okay, so I'm going to try to do a long stretch of discussion, and then I'm going to unpause. That way you can field some answers. All right. So here goes. I'm doing it just because it's kind of better for instruction if you go back and watch it. Somebody's in the chat box. I wish to record. I too. Yeah, that's something you should have done. You should have raised your hand, perhaps. Let's see. Yeah, I really need people to give me a show of hands and stuff. Somebody's already recording. Okay, so that might be everybody. Okay, so here's what we need to discuss. The different facets of the Java programming language when it comes to their syntax. So packages, and as of Java, I believe 9 it was, they added in something called modules. Modules might have been in 8, but I believe Java 9 was really the turning point. So you have something called modules. And modules allow us to collect together packages, but they also allow us to make conditional imports and exports of programming code. So you can make certain types of code available to other users, and you can even specify who those users are. You can also make it possible to use code from elsewhere, but you could also restrict things as far as what you will be the consumer of. We'll get to that much later. The packages you've seen before, and most classes will belong to a package. So the Java recommendations are that your packages are going to be your URL backwards, all right? The reason why it's like that is because when you have a URL, it's going to be a unique name for your domain. So in order to enforce uniqueness, you use your URL backwards. Okay, so here are some examples. You have com.sun.eng. Now, Sun Microsystems originally was the company where Java was created. They went belly up. They then gave Java over to Oracle. Oracle bought out the rest of Sun Microsystems. Here's another one though, com.apple.quicktime.version2. All right, so that's the standard of how you do these things. So when you see Java docs, you should understand that those Java docs are going to be using this format, and that the packages at the top, those are hierarchical subclassifications of code and the pathways to those codes, I should say. Now, classes. Classes for their own part. Classes are a bit different. In the case of a class, you have basically, how would I word it? In the case of a class, you have basically the most basic unit for Java programming. I'll put it to you that way. In the case of classes, what they do with Java is that everything is supposed to be an object or an implementation of a class. However, you could kind of say a bit differently that in Java, everything is class-based. Now, some people might wonder what's the difference. And I'll explain that in a little. I'll get back to that somewhere, I guess you could say, at the end of our first half of this class, all right? But long story short, classes are the basic files that Java uses, and they also double as the basic encapsulating programming structure that makes up one unit or one full program for the Java environment. So now these classes are going to be recipes or schematics for an object, and the object will be based off of the class. For instance, if I had a class called person, I'm going to have some common types of attributes and functionalities that a person may perform, or those attributes may also be characteristics that that person has. All right. In the Java programming language, every program is supposed to have a class in it. Right. So if you have a file that has Java code, that code is supposed to be encapsulated in a class somewhere, usually in the same exact file. However, if you have multiple classes in one file, you'll notice that when you do Java C, they create multiple Java class files, one for each class that was declared in that file. Now, we didn't get to discussing interfaces, but I'll just tell you the following. We treat interfaces in their casing much like we treat classes. So just like classes have an uppercase letter, they start with uppercase, and then every word thereafter is also uppercase. We do the same thing for interfaces, all right? For now, we could just treat interfaces as if they are a similar basic unit of programming, just like classes. And we'll discuss more about that a little later. Now, you've seen what methods are. Methods, or in other languages, they may be called functions, procedures, routines, so forth, right? These are operations that are performed on parameters, or operations that will simply give you some sort of an output or a task that is performed, okay? So we want these methods to be verbs. And the normal casing is that we're going to use a lowercase letter to start the first word with, and then we're going to use an uppercase letter for every word thereafter. So here are some examples. So you have lowercase run. Then you also have camel-cased run fast, right? The F is capital in fast. Here, you'll notice that background is a compound word, so we didn't use capital B and capital G. Instead, we just had a capital B for get background. Now, moving further down here, we have our variables. The variables are going to have a similar type setting as our functions or methods, right? So we're going to start with the lowercase, and then we're going to get into uppercases for every word thereafter. Finally, you have a constant, and a constant is basically a container of data, you might put it, and its value will not change. The way you declare a constant is as follows. These two characteristics must be there together, and every constant must also have a primitive variable data type instead of an actual object data type. So here you have a constant declaration, and the words are all caps, right? So every letter is capitalized, and then there's going to be an underscore between the separation of every word. So let me get to showing you what that means. Here we go. I'm going to do my screen share again for Eclipse. Now I'm going to start a brand new project. So let me go up here to my new project button. No, I don't want the wizard button. I want my project button. Okay, I'll just select my Java part then. All right, so here I am with Java. And with Java, I want to create a brand new not just package, but a brand new program. I think I'll do it from further up on the menu. I wanted to do it from this part of the browser because I know it may be hard for you guys to see like some of my menus that drop down, but let me do a different screen share so you can see my whole desktop. All right, so now I'm gonna go to File, I'm gonna get a new project. This one's gonna be a Java project. And so I'm gonna call this one top down. Okay. Let's go into my default workspace location. And I'm going to keep this on Java SE 15. That'll be good for now. The project layout is going to be separate folders for sources and class files. All right. And then also, I don't really need to add any existing files in. So right now I'm just good to go. And I don't want to create a module right now. That's a little bit more advanced than what we want to talk about. So right here, I'm going to right click on source. All right. And with source, I'm going to say I want a new package. So I'm going to go with a URL that I know very well. Let's see, com.majority of 1 dot www dot, and let's see, the final part should be exhibit. All right. Finished. Now, in that particular package, I want to now do the following. Create a new class. We've been down this one before. Great. So this class is going to be called, let's see, what would I like to call it? Oh, okay, here goes a good one. I'm going to call this particular class Animal. And then Animal, for its own part, will have what you see here. All right, so in my package, Java sees the following. They see that I have a series of subfolders, or at least that's what they're going to convert my packages into, a series of subfolders. And then they're going to see a file called animal, right? So this is animal.java that we have right here. If I had a second class somewhere else, that this compiling just this file alone with both of those classes in it would create not one, but two Java class files, all right? So you could think of classes as follows. The reason why we have them in our program is because when we have those classes, they encapsulate our program, and then they also create class files, which are kind of like, you can liken it to, I guess, a CD to a CD player. So if Java, the virtual machine, were a CD player, our class files would be different CDs, right? Another example would be like tapes in a tape deck, you know, that type of thing. If you remember how tapes went back in the 80s. All right, if you don't, whatever. It just means that I'm a bit older, but not shamefully old. Okay, so here I have a public static void main. Now that I think about it, I should not have done that. So I'm just going to take it out. Here's what I should have done because I want to do this. So I'm going to create an animal, and that animal is going to have some sort of characteristics to it, okay? So right here at the bottom, I'm going to create some characteristics. And I believe what I should create will be, let's see, I could have a Boolean. And Boolean domesticated. Basically, is this an animal that I can let into my home? Okay. Another one would be, I guess I'll make this a string. and the string would be species. Okay. Let's see another one. I could give it a name, and the name can be null. So I'm going to give it a string name. All right. And now that I have that, I know that my animal's going to have a name, it's going to have a species, and then I'm also going to know if it's domesticated or not. Other things I can do, however, is as follows. I could also have a speed of how fast the animal moves. So I'm just going to put that in as well. So this is going to be an int speed, and I'll do the following: MPH. Remember, if I have more than one word, the next part is going to be capitalized. So now, let's create the animal. Every animal is going to have these 4 characteristics at least about it. All right, every animal is going to have these 4 characteristics. So I'm going to create now a means for me to create that animal. I'm going to create a special function or method known as a constructor. The constructor's job is as follows. It's going to create the animal and then send the object file, which is going to be the multifaceted variable that packages all these details together. It's going to send copies of those different types of objects we create from this class into other files that are going to use it. So I could then call this class and its code from another file if I want to create animals in another file. So I'm going to do the following. Then I have to have a function named directly after my own class. This is what we call a constructor function. And to be a bit more descriptive, I think I'll do a Javadoc comment up here. All right. And this right here is going to be as follows. I'm going to say it's a constructor function to create animal objects. All right. And I'm going to leave it right there. Now, here's what I want to do next. I'm going to need a way to interact with these things down here. These are my data members. Okay. So right now, I have a very, very simple declaration of them. I'm going to use a few more simple declarations. So I'm going to have the following. For each of these, I need to have something called an accessor and a mutator. Right? Accessor and mutator functions are as follows. An accessor tells us that we want to access the data. The mutator tells us that we want to change the data or write to it. So one of them is a read operation and the other one is a writing operation. So here goes. Since speed MPH is up first, I'm going to say the following. Int get speed. All right. And get speed is going to do the following. It's going to return speed MPH. Just like that. This is my accessor function. And I think I'll throw a reminder up here. Let's just split this into different categories. So like that, accessor, functions to follow, or methods to follow. All right, and just right here as a reminder, I'm just going to say what accessors are. So we could think of them as get, or read. Okay, so that's one part of our I/O when we want to access our functions. Okay, and then below this part here, I'm going to say the following. Since I'm sectioning this thing off, I'm going to say Mutator. All right, these are going to be set functions or write functions. All right, those methods are going to follow a little later. Now they're complaining about accessor. I'll just add it to the dictionary. Not right now. Okay, so by comparison, and I'm just going to do this one part and then get back to it later, but I'm just going to show you what the mutator would be by comparison. So by comparison, all right, I would have a set speed MPH, and it's going to take an integer. And here's what it does. It says the following: speed MPH equals whatever value you wanted me to put in here. So there we have it. Okay, that's my mutator function, or it's just one of them. Now down here, I'm just going to say that these guys are data members. Done. Okay, so these are the ways that these are the means by which we program classes in general. We're going to have data members, and then we're going to have member functions or methods. So right here, I'm just going to put in another notation. I think I'll do it further up, actually, right there. I'm going to say classes like animal consist of data members I'll just say internal variables. And also methods. And methods for their own part are member functions. Okay, so that's what that means. So you could say that in short, they are composed of attributes and processes that allow us to alter or interact with those attributes. Yeah, I know I said in short, but it turned out to be even longer than the previous comment. So this part up here is my simple multi-line comment. And down here, I have my Javadoc comment, all right? In most cases, when you have a Javadoc comment, they would actually go so far as to put them in two different types of color, right? But no matter. Technically, Javadoc comments are multi-line comments, so no matter. So let's take a look at get speed. This one just allows us to return the speed of the object in question. If I have get name, it's going to return whatever the data type of name was, right? That way I can return name as a value. So using my convention, as you can see, it's a verb. The first letter is lowercase, and then the next initial letter, or the initial letter of the next word, is going to be uppercase. All right, so that's our camel casing. And I'm just going to return name, like that. Next thing I do, I want to get the species. I'm going to return species. All right. After that, next thing I want to do, return or get domestication. All right. So or better yet, I should do a different type of name for this. A lot of times when we use Booleans, we use the word is. So is a number, is not a number, that type of thing. So I'm just going to say is domesticated. That's a better way of doing that. All right. And I'm just going to return domesticated. All right. Save that. Now, notice down here I said that the mutator or the set or write function methods are to follow. So let's finish those as well. Here I have my accessor methods for all 4 of these guys. And I'm also going to use a mutator method. I'm going to use 4 of them actually. So here goes. I'm going to have the following: void set string, or set name, I should say. Okay, and I'm going to say that name equals n. I'm going to say the same thing about the species. And in the case of the species, I'm going to just put a string s in here. And I'm just going to say that species equals s. And then down here, I'm going to do something else. I'm going to say the following: void set domestication status. I should probably just like really abbreviate it. All right, I think that's much better. And I'm going to have a Boolean here. And this is going to be D. Let's say that domesticated equals D. Okay, so here we have it, our set functions, our get functions. All right, let me just save this thing. So now I have animal finished. Okay, so I'm gonna do a little pausing and listen to some commentaries. I see some hands raised. I see something in the chat box. Don't worry, that's exactly where I'm going with all of this. All right, you should be able to unmute now. Let's hear some questions.
Yeah, I know this is going back a little bit, but back when you were setting this up, you were talking about how multiple class files are made when you create a package, I believe.
Mm-hmm.
And I was just wondering the pathways.
Wait. No, that's not true.
Is that not right?
Said,
okay, I'm sorry.
Right. Multiple class files are not made simply because you created a package. If you, what I was trying to say is that if there were multiple classes in the actual, in a single source file, then when you use Javac on that source file, it's going to create more than one class, like a .class file.
Gotcha.
Written as Java object code. So, even if you try to put more than one class in a single Java source file, that's how it's going to end up in the end. And there are some people who, sorry?
Sorry, I just a quick follow-up question. So then the pathway for those class files, would the parents of those class files be back up through a source file up to like for example, if you have your stuff in your Eclipse workspace, I have the next one going down would be like the project files, and then the source file, and then you'd go to your package, and then you finally get down to the Java file itself. the class files within those Java files, those can be from different places, it seems like you were trying to get at. But I was, I guess, a little confused as how they all sort of coalesce.
All right. So when we're doing things in the IDE, I guess you can get kind of turned around. Let me just see if there's a good way for me to show you from where we are. All right, here. So I said that I had a workspace called eWork. Let me go take a look at eWork. I believe it was, let's see. There we go. Here's what really happens. So that part where we say, do we want to put things in a binary or separate source file? This is what Eclipse did for us. And now, as far as what you're talking about, the sources right here, now they take a look at my package name, and all of those different facets are subdirectories. They're subfolders. This is where they put my source files, my Java source files. So com.majority1.www.firstObject, all of those, Java treats them like they're actually subfolders. And the reason why they do things like this is because they're pretty much joined at the hip with certain internet conventions. So this is actually akin to how top-level domains work when you have routing systems, right? There's a machine on the internet actually called com, not Amazon.com, but just com, not Google.com, but just com. Now, com has other sub-networks, and those sub-networks are going to be whatever companies have their own domain. So you could have guys like Amazon, Google, Microsoft, Apple, whoever. Now, when it comes to those particular machines, in many of their servers, they may even have a www folder, which is where they put their files to serve on the internet, right? So that's how they weave through it on the internet, and Java does something similar. But now, notice how here in binary, there's the same hierarchy. Every time we compile, we get a class file. This is what Java runs natively. That cassette that I told you, that is basically, you know, like a cassette for the machine itself, where the machine plays a certain type of medium. This is the medium for the JVM, our runtime editions, virtual machine. Now, if I didn't do this, I would definitely have to put my own files in an unusual subdirectory, and I have to make those subdirectories myself to match the package names. And then Java might complain that, you know, they can't find certain things. Your IDE will do some overhead for you, so you don't have to know those details. But if I have multiple classes in a single source file, let's suppose that person info had a class called person info, which it will, but it also had another class in there called person supplement, right? Once I compile it with Java-C, I'm going to get not one, but two Java class files. Person info is going to be one class file, and person supplement is going to be another class file, in addition to person user. So that's what I meant by saying that if I put more than one class in a given source file, that's exactly what's going to happen.
Gotcha, understood. Thank you.
No problem. Anybody else? By the way, somebody said, I found a fast way to do setters and getters. Yeah. In fact, if you had like IntelliJ, they would just throw it in there for you. So yeah, that's really cool that you found a way to do that. So, you know, that's an IDE thing to create the different functions. However, you should actually know what you're doing. And in the event that some of this stuff is a little too complex. It may not work out for the best. So rules of thumb, people, rules of thumb. All right. So since there's not many more questions, let me continue on. I love to ramble. Okay, so I'll be pausing again in a while, all right? And I'll field more questions. And to restart my recording. So here we go. Now that we have these things up and running, well, not quite up and running, but we have it created, well, let's try to get this thing up and running. That's an important thing. So I'm going to do the following. I'm going to create another file called animal user. Animal user, for its own part, is going to have a class with the main function. All right, so as you can see here, I have two uppercases, right? Because it's more than one word. This time I can click public static void main string args. That's not an error. All right, here we have animal user. So animal user has to do the following. It has to use animal. Now, since these are in the exact same package, it's going to be no harm, no foul with me using animal without any sort of qualifier. So let's take a look at what we have. I'm going to say the following. Animal A equals new animal. And as you can see there, my syntax is just fine. Now, once I come down here, I can say the following. And this is assuming that, I was able to get the animal allocated. This is just creating a new object. I'll put it up here for readability. I'm going to create an animal object, or what I can call a user-defined data type. Or user-defined data type. That's a better way of wording it. All right, because that's how we really should be looking at it. It's a user-defined data type, just like how we had int. Now we have animal, right? And that's something we created. So, just going to say the following: system.out.println. We created an animal. All right. With that, just hit save. So now I'm going to run this. As you can see, we did create an animal. So the reason why I did that was because if I ran into an error, this part right here, if I ran into error here, then I wouldn't really get down there without a whole bunch of problems. All right. And now here's the thing. I got to add some sort of detail to this. I have to make it sound rather consequential. All right. So here's what I'm going to do. In my next segment, I am going to use my set and get functions as well as my data members. All right, so we used the constructor as you saw before. That was how we called the constructor. We set new animal, okay? And then by having that, we now know that the animal was created and that the following variables exist. These data members. Okay, so right now, let's see. I'll give you a 5-minute break. You know what? I'll give you like a 7-minute break. All right. And if you have any questions, you could also ask. I don't know about 20 minutes, but that's funny. All right. So let's get back to what we were doing. So here we are in project top down. So here we have animal. We created the animal class successfully, and we even used it using animal user. All right. So this is the very basics of how you can use a multi-file program. Now, we could have used many more files. None of that really matters. It's basically the same principle. But now let's talk about what's going on under the hood of it all. So we have something called public class animal. What public means is that I can freely use this library no matter where I'm trying to call it from. So even if it's not in the same package, even if I try to call certain parts of animal directly, I have a way into the animal class. All right. So that's my passageway into the animal class. So now I didn't give any of these any additional qualifiers. All right. What that means is that in the absence of a qualifier for member access, what I'm going to have is a package level access to everything that's in here. Now, that's not necessarily the greatest thing ever. And the reason why is because when it comes to object-oriented programming like Java, the concept of information hiding and encapsulation is usually prioritized. So encapsulation is what we have right here, where we have a class that later on will be used as an object, and that object has certain members to it. All right. When I created a new animal, I got an entire encapsulated group of variables and the functions that work with them. For instance, let's suppose that I come down here a bit. I use the word a, or the variable a, and I use dot. Now you can see everything that's in that class. So I had domesticated, name, species, speed, MPH. Then I also had things such as get name, get species, get speed, and is domesticated. All right. So the way you read this whole thing is as follows. The first word is going to be my identifier name or variable name. And the second word, this colon here, tells me that this is the data type for this one over here. All right. And finally, I have the name of that particular class that they belong to. Same thing here. I have name, string, animal. All right. So name is a string and they belong to animal. Species is a string belonging to the animal class again. Down here, if you see get name, you'll see the return type comes after these colons. Right. So get name has a string return type and it belongs to animals, so forth and so on. Now, what we want to do is to create a way of accessing our class components in an orderly manner. So let's suppose that we have the analogy of an ATM. We want to get money, we want to deposit money, right? Those would be two functions, but that doesn't mean that we want somebody to break into the ATM and take our money, especially directly. So here's what you do. I'm going to turn around and go back to my animal part. Let's suppose that these were sensitive details. So now I'm going to protect them as follows. I'm going to privatize them. So private, integer, speed, RPM. This is also going to be private.
Why are you making it private?
Oh boy, you talked while I was, oh boy. Let me edit that part out. Sorry, I meant to mute things. All right, I'll answer that one really quickly, but please don't call out. I'm making them private so that they can't be accessed directly. That's important. Remember, encapsulation. I'm trying to make sure that sensitive details are not accessed directly. All right. Any more questions before I turn the recording back on? All right, guys, here goes. Okay, so here we go. So here I have something that is a bit unfamiliar, and I'm going to explain how it works. So let's go back to animal user and see how this whole thing has changed. I'm going to hit a dot. Let's take a look. As you can see, those data members, they disappeared. We no longer have access to them. Mission accomplished. Now, remember what I was saying before about sensitive details. In the case of the animal, it may not be so clear why I would want to make these guys private because it's not so sensitive in the real world. However, when we use object-oriented programming, by default, we usually make data members inaccessible to the outside world. Instead, the way into the class and its different items is to use our member functions to access them. Member functions for their own part may also have different types of access levels. So I'm gonna, for now, use the following. I'm gonna say this is public. In fact, they're all gonna be public. And despite the fact that they're public, they can still access the data members, but they're gonna access them indirectly, not directly, but indirectly. So they're going to reveal pieces of the actual object's data, but you'll have to go through some protocols first, right? This is standard practice for any sort of object-oriented programming language. So things like Python, Ruby, they always use something similar to encapsulate and then make indirect types of access to the more, I guess you could say, hidden underlying details. This is basically the way we do it for object-oriented programming. Now I'm going to show you what this means. So let's take a look at how the functionality of our program has changed. I'm going to go back over to animal user, and I'm going to say the following. Here I want to do the following. I want to say animal dot, and I'm going to go with my set functions. Set species. Set species. I'm going to say this is a cat. All right. And this is how I actually, work to, I don't want to say modify, but how I work to interact with certain more sensitive details that may need to be removed from direct access, right? So I have to be able to work on the object itself. Now, some people might say, well, why don't we change the whole thing directly? And normally, if you try to change it directly, if it's already private, you're going to get an error. But another thing is that at a later point in time, you can also change the very nature of the object's access level and, quite literally remove it as an option for unwanted access. Another thing I can do is have the object be part of uh, another class, kind of like what I have with string name. And so once I do that, the interface, you might say, or the accessibility would once again change so that the underlying class has a bit more guess you could say, integrity up front, right? If I move through a bunch of objects and I don't know that beneath it all there is a certain group of details, then that may be a good way for me to hide more sensitive information by suppressing it and then building some sort of a black box type of software contraption where, you know, the whole black box takes an input, gives you an output, but it doesn't tell you its underlying details. All right. So for those who don't quite get it yet, just imagine that I have something sensitive that I'm saving. And that's actually why we go about doing this. When it comes to object-oriented programming and information hiding, we say the following. Basically, data is revealed on a need-to-know basis. So the only time when we can really decipher what an object's data is if we go through either that object or some other object that has a connection in which it has that special, you might say, privileged situation where it can look at that data directly. So it's not going to be available to the outside world, okay? Gotta use set name. And the name I'm going to set is, let's see. Cool the cat. That'll work. Now, I have a couple of others. So what about the domestication? Let's say the domestication part. Oh, let me not do that. That's to get the value out. Sorry about that, guys. Domestication part. I'm going to set the domestication status. The answer is actually that it's true. It really is domesticated because it's a normal cat. And then finally, last but not least, I'm also going to set the speed or MPH, all right? I'm just gonna say it's 12 miles per hour. So this is how I use my setter functions. Now, for my getter functions, they're gonna be a bit different. Here's what I'm gonna say. And by the way, they don't have to be placed in another function. You can use the getter functions, you know, by themselves, but I'm just gonna throw them into system.out.println. And now what I'm gonna do is as follows. I'm gonna say animal A has the following details. Okay. Down here, I'm going to print out what those details are. So here's what I need to do. System. Okay. And let me just put my semicolon there. Here's what I want to say. A dot get species. This guy right here. Plus I could actually prefix it with a string. Let me just say the following species. All right, so species plus I shouldn't have that right there. There we go, get that sign out of there. This plus is just fine. And I'm going to say the following. I'm going to say name. Up here, I think I should have done that as well. There we go. And so for name, you have the following. It's going to be a.getName. All right. And then now again, for the following part, I'm going to have, let's see, speed MPH. All right. Bring that one down. So now the speed for this thing, I'm going to say is a.getSpeed. Okay. Now for the last part. This is for whether or not it's domesticated. Status. Just going to put a new line back here. And I think I'll put a tab there on the next line though. Okay, so now I'm going to do the following. And I'm going to do a dot. And I should have the domestication status is right down here, is domesticated. Okay, and with that, I have my program. I'm going to just hit save. And then I'm going to compile it. Okay, so here's what we have. We created an animal. Animal has the following details. So species was cat, name was cool, speed was 12, and the domestication status is true. I should make it a bit more readable. There you have it. Okay, so let's field some questions. All right, everybody, how you doing? Questions, you guys? Let's hear them.
Professor,
Yes.
why do we need to use an empty constructor?
We don't, but I'm just using the simplest case.
Oh, okay, so there's no difference if we use an empty one and if we just don't.
So you're going to want to pursue that on a case-by-case basis. So good coding design would answer more questions about that than me trying to sum up what you'll run into in life. You could run into anything, but it's a matter of, proper judgment more than anything else. I'm just doing it in this case so as not to compound too many details and throw people off and make them think that, this is how it has to be done at all times, and just try to go from the bottom up.
Okay, thanks.
No problem. So I will be making other constructors and showing you guys how those work. Was that Nikita I was just speaking to, by the way? Somebody asked you, what's the point of animal in the animal.java? Animal is a constructor function. It allows us to create an animal object because we did not previously have an animal object. So we had to define one. So if we make a user-defined type, our user-defined type is going to be an object, and all objects have to send information to the compiler to let it know what the definition of that object is, how to get one started and up and running. So now, in other parts of, I guess you could say, different programming languages, what they would do is they would actually look at what you have in that class, and they would start to measure the size of all of these data members and also what it takes to store the member functions. And so when you ask for a new object, you literally ask for a buffer of that combined size. And that's why we have constructors, because they send back that type of information of how much space is needed and what the spaces are needed for, because we now know what the data members will be and what the methods are.
Professor,
Yes.
does Java have like the concept of like a default constructor? Or like, so say
yeah, I know what you're talking about. Like if you don't define one.
So right now you created a object of animal, and then you went and set some variables using setters. So like, say you don't, is there a way in Java when you define or like declare a new animal, all those variables are preset to a certain thing?
Yeah. You could do that. I mean, there's all sorts of things you can do.
How would you do that? Would you define that right there on like line 19, basically?
So if I say this is equal to, as you can see, there's no error here. That works.
Okay, so what about when you define or declare a new object, passing in variables at like the declaration?
All right, so that's something I'm going to get to next.
Okay, got it. Thank you.
No problem. All right, people's questions. So I know that the question is coming up, what if this guy here did not exist, animal? All right, so let's just take a look at variations on a theme. All right, everybody, so here we're talking about variations on a theme because there are quite a few questions, and those questions are all pretty valid. So although this stuff is probably discussed in the book or somewhere on the internet where it might be easier to find or search for, let's just take a look. Notice how here I still don't have any errors in my Java program. I've taken out the constructor for the animal class. All right, so if I go to animal, you'll see that there's no more constructor there. I don't have a problem with that though. You see, if I do something like that, they'll just basically give me a blank constructor themselves. So now that I've done that, let me just make sure I have saved both of them. Yes, I have. Just going to run this guy again. All right, so that's how that works. I basically called a constructor that was created for me by Java or the Java virtual machine, and it had nothing to do with whether or not I defined it ahead of time. Now, let me just, let's see, put my, there you go, put that right on back. And also, let's suppose that by default, domesticated is set equal to true. All right, so only if I have something like a tiger will I change it to false, you know? Let's see, what else can I do? I think I'll leave it at that. So that's going to be a default value given to my domesticated field. By default, it's going to be domesticated. Now, another thing I want to do. So if I want to change the parameters, here's what I can do. I'm going to do the following. I'm going to create a couple more constructors. And this is going to allow me to overload my function. Overloading functions means that you can actually call on one of many similarly named functions. And those similarly named functions will be called based off of the parameters you give. So in this case, let's just suppose I had a string name. And a string for species. Or better yet, let me just make it super minimal. All right, species, just like that. Now I'm going to do the following. I could say this in one fell swoop. So species equals S. And that'll work. All right. But now let's suppose that I do the following. Let's suppose I have a whole heap of things I want to enter. So I'm going to have animal again. And now up here, I'm going to have the following. I'm going to have a string, which gives me the name. And after this, I'm going to field some questions. I'm going to have another string. That's going to give me the species. Then I'm going to have another integer for speed. Another integer, a Boolean value. This is going to be for domestication. All right, let me just drop it there so that it's readable. And so what I'm going to do is as follows. I'm going to start setting these things. So take a look. I can use these functions to set my different items. All right. Right up here, you've seen that I was able to initialize members by using direct equations, right? So species equals S. I can also do the following. I could say set name and put N in there. No problem. Say set, let's see, what was the other one? Set species, all right? wait, no, I don't want to do set species. I want to do set dom stat. There we go. And well, since that was already true, I'm not going to touch that one. I'll tell you what I am going to do. I'm going to instead set the speed MPH. All right, so that'll be the one that I'll use because I don't want to mess with that, because then it'll be harder for me to really show you guys, ladies and gents, how this whole thing works. So the speed MPH, I said it was like, let's see, SPD. All right, throw that in there. Put my semicolon there, and it's all good. So let me just make it clear to you. Here's one way that we can initialize members in the constructor. Here's another way to initialize members in the constructor. Our final way of initializing members in the constructor goes as follows. This, meaning referring to the current object, dot, and let me just show it to you in here. In this case, I can use this and then go to string s, but here, let me do it as follows. And I want to put in here s. Okay. And they're arguing with me. No problem. No, I don't think I called this like that directly. There is a way to refer back to this particular object, but I'll leave it at that. And I'll probably have to explain to you the word this as well. So maybe I shouldn't bust out with this just yet. So let's see. I'll just do the whole speed part or the species part as is. But I'm not going to leave that part alone. I'm going to get back to it. All right. Just going to leave that right there. Now, take a look. I have more than one called animal. Okay. So now if I go to animal user, I meant to save animal, sorry. If I go to animal user, I could do the following. I'm going to create another animal. This is going to be called A2 equals new animal. And take a look at how this is different now. I'm going to put in here tiger. Actually, no, I won't put that there because the domestication status is still true, and I'll have to fix that in order for it to make sense. But I'm going to put in there dog. Then I can also make another animal. This is A3. It's going to be another new animal. And here's what I'm going to throw in there. I'm going to say that for this particular animal, I want and let me just check my constructor to see the order that I put these in. The name, the species, the speed, and the domestication. All right. So it's going to be a falcon. But first, I should also have the name. So the name of this falcon would be Hayabusa. Put a comma there. All right, put another comma here. The next argument was as follows: speed. And so this is 1 to 0. Next one is domestication. I mean, they can be domesticated, but not always. So I'm going to say, let's see. Actually, I should have left the domestication part out, maybe. I wish I did, but here goes. I'm just gonna use set DOM status. And I'm gonna throw D in there. I already have what I need for dog. Since I didn't define it with dog, I can, show you the default there. Go back to animal. I should say animal user. So this particular animal is going to be true. All right, just for that one though. Now let's suppose that I do the following. I'm going to do the same thing over again. So I'm just going to say that I have the following issues or cases. And I'm going to field some questions in a minute. Just going to paste that part over. I'm going to change this animal to, this is going to be a printout for A1, which was that dog that I made above, all right? Or I should say A2. So the dog is going to be there. But now since I didn't put anything in anything else besides domestication, you're going to see that there are going to be some null values. And if I come down here and do the same thing, all right, here it goes. This is going to be A2. This one's going to be A3. All right, and let's just see what I get when I compile and I look at what I have and run it. So I'm going to run this as an application. All right, so let's see what we have. So the first case was the one that we had all along with the cat. The name was cool. Speed was 12. Domestication status was true. Now, remember with the dog, I didn't really define everything. So I have default values for at least 2 areas. Take a look. Species is still dog, but the name is null. We never assigned that. And the speed is 0 because we never assigned that either. The domestication status is true, but I didn't assign that. Here's what happened. They came down here and they saw that I still had that domestication status right there. Now, in the third case, with the falcon, take a look at what I have here. It says A3, I have a falcon, Hayabusa, 120, domestication status is true. What if domestication status was false though? If I replace that with a false, here's what I get. Gonna rerun it. And as you can see, the domestication status of true was overwritten, whereas before, when it was left untouched by dog, true remained there. Okay, so now let me just stop and field some questions. All right, everybody, let's hear it. I know there's at least two of you. There was Jonathan and somebody else raised their hand. I haven't forgotten. So whoever has their hand up, I guess. Wait, I think Connor may have raised his hand. All right, let's hear something, peoples. Let's hear some questions. You could just unmute yourself. Just, hold down the space bar, Alt Y, whatever. How's it going?
Yeah, it's good. I'm confused at how did it know that dog was the species name and not the name. Because I thought the name, like in the method, if you go back to the animal class.
Okay, let's take a look. Okay, so you're asking about
Constructor. It said that the first Oh, okay, never mind. I didn't realize we had a second thing for just for if we only have one thing in the parentheses.
Right, so that was what's called for dog, and it only picked up on the species. However, the last one was for all four.
And how did you get how did yours have that domestication status was true for dog? Because I had that as false.
Remember I set it equal to true down here as a default.
And
so
yeah,
what happened?
Yeah,
okay, no problem.
I get that part. How come you have species equals S and you didn't do set species equals S?
Okay, so from within the class itself, you can call your own data members even if they're private. So it's kind of like if you have your own secrets, you know what your secrets are, but that doesn't mean you're sharing it with the world.
Yeah.
Right.
How come for the rest of them we called the set ones instead of just the actual?
So that was just to show you how code reuse can work. And that's one thing you can do, especially if you feel like you want to keep it clean, or in other cases, let's suppose it was an elaborate process. And so the set name and set speed or whatever, those parts right there would take care of the elaborate process for you and allow you to eliminate a whole lot of code. Then that would be a good thing. I mean, I know that right now it may not be so obvious to see it, but let's suppose that these were actually objects in themselves. And then you had to, send in a bunch of parameters. Then it becomes clear that you want to use something like this because, going down on that deeper level and then doing everything piecewise would then be a chore.
Okay, thanks.
No problem. Let's hear something else. What do you guys have? Okay, got Emily and Mohammed. Emily.
So if you use it this way with parameters, do you still need the get and set that we had, the bunch of lines that we had after this?
Of course you should or do. Take a look, because remember that it was also, you see here, I'm changing the values, or I'm working on those values from within the class itself. However, the outside world has a different set of rules. They can't just run rampant knowing that I have, private data members that they can't access directly. So over there, I have to then use the actual object name and then use the public data members, which are designated for the outside world. And by means of those, I can make updates to the object. So if a person were, let's suppose that I had something like a person being born in a hospital and you have their birth certificate, right? the birth certificate part would be kind of like initializing the constructor. But what if the person gets older and they change their name and their address? You know, it doesn't mean that they're being born all over again. Instead, it means that, you know, there was an update to their details. So that's how the whole thing works in that particular case. Make sense?
Yeah, but in animal where we're creating our constructor, we
Okay.
still need all those lines there because we're using it with parameters.
Which one?
So here we're using the parameters animal string n, string s, dot dot dot. But do we need it when we're doing like the later lines here with like set like public string get name, return name? Like, do we need all that? No, in animal, not in animal user.
Okay, in animal, public string get name.
Like, do we need all of these? You always need it?
Usually. So here's the thing. Let's suppose that you really do have something that is so personal or private that you don't want anybody touching it. In that case, you're going to make your class a little bit different so that there's not really much of an entryway in, right? So to kind of gut the thing and make it like asymmetric, or, you know, to take away certain abilities, there's a couple ways of going about it. I'm not so sure that you would want to leave it up to a method or two, but you can if you have very specific cases, right? But in this case here, we're just coming up with standard ways for the outside world. That's why these guys are public, to be able to interact with the object. But remember, these are specifications. So we're not saying that it's mandatory one way or the other. We're actually creating an interface to the outside world. So kind of like using that ATM analogy, you know, if I don't want people going into the machine, smashing it wide open and taking the money, maybe I should have like a different way that the machine works. So maybe there'll be a touch screen, and the touch screen will, you know, decide whether or not people have money dispensed to them. And you know, so it guards something that's sensitive, but it also creates an interface for, you know, designated users who have the right to use it. Does that kind of make sense? In other words, it's like I said before, the information hiding principle that we use in encapsulation and object-oriented programming, it removes details farther and farther away from the end user. That way you can establish protocols on how the code will work or be called upon. So you're basically creating policies for access. All right. But yeah, it's gonna have to be like in different cases, it's gonna have to be good judgment on the part of the programmer to decide whether or not things should be pulled out or added in. Muhammad, oh, I'm sorry, keep going.
No, I was just saying, okay, I understand now. Thank you.
All right, thanks, Muhammad.
Yeah, just a quick question. For your animal class, you have 3 constructors or just 2?
I have 3.
Yeah, one of them is empty, right?
Yeah, that was the first one. But remember how previously, when I erased it, they also had like, you know, that there was, the default was still there. It was still there even when I did erase it. So, you know, I can do the following. I can take this guy out completely. And even with these other 2 here, I can still call the blank one, no problem. So if I have like animal right here, right? And I save it like this, and I go around to animal user, let's see what they're gonna say. They shouldn't really be complaining, but let's just take a look. Constructor is undefined, is it? They may have changed it. They may have changed it. Maybe I need to be explicit. Let's just see.
That's what happened to me.
Oh, really? It didn't work for you?
Yeah, so I realized I thought I had to create an empty one. That's why I was asking. I think I read in the book that they said that it creates a default constructor, but once you create your own constructor, it won't create the defaults.
Right. So, you know, and that makes sense because you're really choosing between multiple items. So, you know, if you don't have a default, then that's what you get. But if you do have other constructors, you're going to have to then start making it clear that they have overlapping functions, but under different circumstances, like the circumstances we use right here. All right. More questions, Mohammed?
No, that's it. Thank you.
That's just your hand up. All right.
Oh yeah, I'll put it down.
No problem. I was gonna. Who has a question? No questions, anybody? All right. So since you have no questions, what I'm gonna do is I'm gonna actually start taking this to yet the next level. So here you see what it's like for me to make a constructor and a class and functions and things of that nature. Now, normally what we want to do is be able to make programs that are a bit more, how can I say this? A bit more specific and unambiguous. Because, I mean, if I have an animal, you already know that I'm going to have, you know, like different parameters for it. But what we don't know is what type of animal it may be. So let's suppose that I'm a vet and you say that you need to bring your animal to the hospital or whatever, you know, the animal hospital. Now, if I'm a vet and that's really the case, I'm probably going to stop to ask you, what kind of animal is it? All right. So here's what I need to do. You know, sometimes you have people who are experts and they're specialists, right? And so let's suppose that I am a specialist and I need people to specify much sooner what it is that, you know, they're using or doing or things of that nature. Here's what I'm going to do. I'm going to create another class. And that class can be pretty simple. And the good thing is, because we have classes that are simple, we can start to, you know, we can start to imagine how things span out more. I'm going to create a class called cat. All right. Now, cat is going to do the following. You see this part that says superclass? The superclass actually is going to be the class of code, such as animal or animal user, that cat is directly related to. Now, I'm going to do the following. Normally, I would not want to like fill out this part right here with the browse and all that. All right. But here's what I'm going to do. So I'm going to have this part be a class that actually inherits from another class. I'm creating a subclass.
Professor, we can't see what you're doing.
You can't see what I'm doing.
You're only sharing the Eclipse window, not the whole screen.
Okay. So let me just, sorry about that. Okay, everybody. 3, 2, 1. I'm going to like kind of reverse and go backwards. And in a few seconds, you'll be seeing what I'm seeing. Okay, so here we go. So you've seen what classes can do, and you've seen what objects can do, right? And because of that, in this particular case, what we want to do is be able to be a bit more specific about the special cases. So I'm going to start a new class. Take a look. Now notice what it says here, superclass. This is the class that every other class extends from, unless you say that another class is, that there is another class that is its superclass. So I'm going to explain that terminology in a moment, okay? But here's what I'm going to do. So I'm going to create that class and move forward. The class I'm going to create is called cat. I think I'll leave it as cat singular. So now I'm in public class cat. Here's what I'm going to say about it. This guy right here, it extends animal. And what that means is that every cat is going to be a type of animal. Animal is the superclass, cat is the subclass, all right? So you might be wondering, what does that mean? Here's what it means. It means that even if I don't make any more changes to this whole thing, cat is guaranteed to have the following. It's going to have all of these functions here because they were public, all right? And it may also have data members, assuming that I declare them properly. Now, as you can see here, I have this thing that says data members, and under it, it says private, 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 private. Because cat is trying to extend from animal, the subclass won't be able to access the private data members. Just going to say the following. I'm going to put my constructor here. And in my constructor, I'm going to say the following. Super. All right. I can also create another constructor. This is, by the way, going to call animal, the original one with no arguments. Now, in the other case, I'm going to do the following. Let's suppose I have cat. And in here, I'm going to take the following in. I'm going to have a name, string name. And I'm also going to have an integer. SPD. And the domestication status. Here's what I'm going to say. Now, I could set things equal right here, right? But instead, I'm going to say the following, super. And you're probably wondering, what does super mean? Super means call the superclass, which would be some class. Well, in this case, it means go to the superclass's constructor, all right? So if animal has these different constructors up here, I already know what type of species I have. So I'm going to call animal. And I'm going to have these 4, but I'm going to leave out in my arguments to cat the species part because the species is already clear. All right. So in this case, what I need is as follows. It's going to be name. It's going to be species will have to be cat by default. Okay. And after this, I'm definitely going to get to some, comments. So let me just take this string part out. That's not supposed to be there. And let me also take out this int part and this Boolean part. Okay. Semicolon. All right, so that's a call to my superclass. I'm calling this other function, the one in animal. This one here. So I'm just going to make that clear. Calls. Okay. So now I have something called cat. Let's see what I can do in my normal interface. I'm going to go back to animal user. I'm going to say the following. I'm going to say cat equals. So cat C equals new cat. All right, and let's see what we get from this. I think what I want to do is put in just a name. Maybe I should have also have, made that a possibility. No, I won't be able to do just that because if I do call on something, then it's gonna have an issue. So here goes. Remember, I didn't define any set or get functions. So I'm gonna have to then pass in a name, and I'm also gonna pass in the whole string part and SPD and Boolean. But here's the order in which I'm gonna do it: name, speed, Boolean. So Thomas, $15, true. All right, and then with that, what I'm going to do next is as follows. I'm going to take this part here. And let's take a look at how it works together. All right, so I'm going to say cat. And let's see, what did I name? Let's see, so cat C. Has the following details. Now that I've saved it, let's see what happens when I run it. All right, so cat C has the following details. The species is cat, the name is Thomas, speed is 15, and domestication status is true. All right. But now there are certain things that I cannot quite do from cat that easily. So let's suppose I tried to have a set function, or a get function, I should say. And I'm going to do the following. I'm going to say public, and it's going to be, let's see, I'll do public integer get speed. All right, let's take a look at what happens. This guy is going to return speed mph semicolon. Now, let's take a look at what we have here. Let me just first save this. All right. And notice that animal.speed mph is not visible. So that's giving me an error right now. This part down here, I can't see it so as to change it because it's a private member. Now, if it were protected, I could. The reason why we declare things protected is so that they can have some of the provisions of private and have a few more abilities that may carry over, such as the inheritability of public, right? Public things are inherited rather easily. That's why I was able to, call the super functions. But now, as you can see here, the field was not visible, but now it is. All right, so that's one case of visibility. But now let's suppose I did the following. Public string get name. All right, I'm going to be reduced to doing the following if I ever want to find out what the name is. Here's what I have to do. I have to say return super dot get name. Because there's no other way for me to access the name parameter locally. So as you see, I have to use an indirect method to get there. All right, so here's what I want to do really quickly. I'm going to run this very quickly and then listen to some questions. Now, if you watch me try to run this thing, it's going to get an error. Let's see what I have. What I should have done was make sure that the error would have happened. Let me just go back to animal. So this thing was made to be protected, so that's why I was able to access it. Let me just make sure that there is a part that is, there we go. So Boolean domesticated. I'm gonna actually leave it the way it is. Let's take a look. So going into cat, I'm gonna do the following. Public Boolean get DOM status. I'm going to return is domesticated. Of course, in this case, they should be giving me an error somewhere, and they're not doing that. That's why. Sorry, guys. Of course, they were going to have that problem. Here's what I need to return. I need to return the field directly. So I'm going to return domesticated. There we go. That's going to give me an error. Okay, let's see. They didn't use the return domesticated that I wanted them to. Field is not visible. That's how it's supposed to be. Let's see. I can shorten this guy like that. I'm gonna call him get dom st. That way they don't call the super function. So I had cat c down there. This is supposed to be c domesticated. Is domesticated. All right. So now I have that current function that should be erroneous. There we go. So as you can see, there was an unresolved issue. When they called is domesticated on cat line 23, that one right there, the whole tracing program caused it to flag an error because in animal user 51 is here. I tried to call C's version of is domesticated and it cannot by any means look into the private members of another class, even if it is inherited from, all right? It can only do that on protected and public members. Otherwise, the only other thing you can do is use some sort of inherited method to try to weave its way into this superclass. All right, so let me just pause here and take some questions. All right, everybody. Let's see. I've seen quite a few people with some questions. There was somebody who came before Muhammad. Was it Bob or something? Taiwan? Could you zoom out? There you go. Muhammad.
Yes. So I want to ask, for the protected stuff, which files can't access that?
Who cannot access protected? All right. This is an iffy question, and I'm going to tell you the following. It could depend on the language itself. Java does not implement protected like, say, C++ does. So in certain other languages, protected is simply to make sure that sensitive details can be inherited into a subclass. So if I wanted for the data members to be automatically in cat and directly accessible from cat, then they all need to be protected. However, in other programming languages, they would not allow you to access it as you would a public data member. Instead, it would behave like it's private, with the exception that it can be inherited into a subclass. So now you're asking, who cannot touch the protected members? In Java, you would say that it cannot be accessed by anybody outside of the package. So anyone outside of www exhibit won't be able to access the protected members. However, in other languages, it's understood that it will not be accessed by anything that is not either the class or the subclass. Of course, in C++, they also have something called friend classes that can access the private members, but in general, it's only one step up so that it has the similar features as private, but it can still trickle down into subclasses and be a protected member in those subclasses.
I got it. Thank you.
You sure?
Yeah. I mean, what's it called? So you said it has to be in the package, right? So
Yeah.
anyone in like any files under that domain name, they can access the protected files, right?
So yeah, anybody in the same package can. But let's just, so if you take a look at what I have here on this side piece right here, animal user, yeah, they can access the protected members of, or I should say cat and animal user can access the protected members of animal. However, in this other project, like file IO and file IO character set example Java reader, those won't be able to access the protected members because they're outside of the package. So that information is closed off to them. But now, if it were, say, like a language like C++, right? Cat would be able to access the protected members. Animal would be able to access the protected members because they belong within animal. So the original class and its subclass can both access the protected members. However, animal user would not be able to, because then it would be seen as, an outsider of the inheritance scheme, and that outsider would not have the permissions or policies necessary to be satisfied so that it can access that data. Yes.
What chapter would the supersets and stuff be on?
Okay, so it's called inheritance. All right. And I gotta admit that when it comes to inherit, so this is chapter 8. All right. My favorite, however, is the Java tutorials online. Those are just awesome. Hold on, let me just take a look at some other things though. So they're probably going to talk about the keyword super, using super. All right, that's there. A second use for super. So if you've taken a look at what I did, I used super twice, and the way I used it, I used one. The functional notation allows me to call the constructor. So if I treat super as a function, I'm calling the constructor. But the other one where I had super dot, all right, that meant go into the super class and get that particular function. All right. So that's what we had there.
Well, you're about to show a separate website?
No, this is the actual book. This is the book. You mean you're asking if about the Java tutorial website?
Yeah, you said that there's something else that you was about to.
Oh, right. So I just wanted to make sure that I wanted to cover this keyword, but I'm also going to show you the tutorials on Java. I like the tutorials on Java because they're practically exhaustive and they have good examples for basic beginners. Everything looks like a tutorial. Let's see, what do I have there? Java tutorial. For classes. All right, so this whole thing right here is going to be a whole lot more condensed. And I think that's just so cool. All right. And here they have declaring classes. Classes can also be made private. So modifiers such as public and private, you can use that for class declarations as well. And here they also go over what the spelling should be like, capitalized initial letter. Right, and then there's a parent class. Let's see. Now, we talked about creating and using objects and returning values from methods. So this keyword. Okay, so we talked about how classes can refer to superclasses using super. This allows for a class to refer to its own class. All right. So it's a self-reference instead of like a reference to a superclass. Let me just see if I can like abbreviate this part for you. So in this example that you see here, they have a constructor for this class called point. Now, this right here would be redundant because as you've seen before, we have X's and Y's, and we were able to declare our data members equal to whatever we wanted. Of course, in this case, because they have int X and int Y set into their constructor, they made this keyword necessary because now it's saying the X component of this particular class that's already established in the data member field. All right. As opposed to it, the X that is up here. So you can use this to refer to other constructors. Now, here's what I was trying to use. So this, the same way you use super, you can also use this. So here, let me show you how it goes. One second, and then I'll pause for more questions. Okay, so you've seen how we use the super keyword. Take a look. This is the this keyword. It refers back to the actual calling class itself, or the actual calling object itself. Now, some people might wonder, how do you do that? And the truth is that in certain programming languages, there's actually something called a zeroth argument, which means that before the first argument that you put into the parameters, there's an implicit passage of yet another argument, and that argument would be the class itself, right? So there's going to be some reference back to the class itself. So in this particular case, you have class rectangle, and they have these private data members. And then here you have the constructor. But the constructor calls this 0011. Now, what would that correspond to? It will correspond to this constructor down here. All right. So this one initializes by calling the initialized constructor down here. This one also does the same thing. This 00, and then it passes in width and height. Okay. So now in our case, let me just maneuver through the clutter. There we go. In our case, we would have the following. We have the different animal constructors. All right. And so what I would need to do is as follows. So I said that up here we had string species. So this can actually be made to take on that value there. All right, let's just check with their constructor call must be the first statement in a constructor. No problem. And now that should work. Okay. So now if I use this right here, it's just going to go up and call that one right there. Then these other member functions will call, their respective code in the remainder of the program. So now I'm going to hit save there. And here's what I want to do. I'm going to finally take these guys and I'm going to change them all to protected members. And the reason why I'm going to do that is that I can then work on the subclass a bit more. I feel like I showed you what I needed to show you by way of keeping them private and showing you that the access to them cannot be taken for granted. All right, so now that you know that protected facilitates inheritance and it makes it easier for the subclass to access certain members, it would then allow me to have something like this in which, as you can see, I'm not necessarily taking a data member that I can't access and trying to send it back. So now with this being done, I can actually use animal user again and run it again. This time, no error. All right. So that's what we have there. Okay, so I'm gonna pause and get a few more questions out of you all. Questions? Wowzers. No questions. Okay, so who gets this 100%? Let's just see by a show of hands. 1. Okay, we got 3 people. Leave those hands up. I really want to be able to count them all, see what the ratios are. Okay, so let's see. It's 1, 1. Who gets it 100%? Okay, so that appears to be, let's see, maybe a third of the class. I have 3, 6, 8 hands out of 31. That's only a quarter. Guys, I don't even know if you're listening to me. Okay, so I'm gonna put the hands down. Ah, somebody else raised their hand. A new challenger has entered the ring. Great. Nobody else though. All right, so that's very revealing. By a show of hands, who does not get it 100%? Wait, Chelsea, you raised your hand twice. You don't get it, and you do get it 100%? Okay, and I got something in the chat box also. You forgot how to raise your hand, Alt-Y. Or you can also go down to the reactions part. Phone was Iggy. Who's that? Chelsea, are you talking about rap music in this class? We don't talk about rap here. All the good rappers passed away, unfortunately. The majority of them lying. You know, I always find that out the hard way when I give out an exam. A lot to remember. Practice can help. What are we voting for? We're voting to find out if people understand this stuff 100%. To be honest, I forgot how to raise my hand. Impossible to get 100% without practicing. Phone was Iggy. All right, I have to take your word for that, Chelsea. Like 85%, just like all my classes. That's what I'm saying. Yes, I figured it out. I am a Java master, says Adam. I don't think I understand it fully, but good enough for an assignment. I understand the best I could at this stage. Need more practicing to get it 100%. All right, guys, so here's what you're going to need to do. That's the way you really see it. I agree. So I'm going to take this moment. And I am going to go into our assignments area. Let me create a new folder. Assignments. And let's see, within our assignments folder, just gonna upload the following. This will be assignment 1. Okay. And I believe I will be taking let me see if I could just drag and drop them over. Yeah, the instructions are in the Dropbox too, but I will go over that. Can't believe they only loaded up one file at a time, whatever. Okay, so let me also create a new file. All right, people who want assignments, good for you. Here goes. Assignment number 1. Assignment number 1. Okay. Here we go. So, given the enclosed Java files, I shouldn't have the bold still on, sorry. Here we go. Add Javadoc comments to all 3. You must remember where Javadoc comments are to be located. In addition, you must create following files: dog, which inherits from animal, Tiger, which inherits from cat. And let's see. That's a good question. What are you supposed to write in the comments? Homo sapien. No. Remember, the Javadoc comments have a function all their own. So that's part of what you need to know about Javadoc comments. That way, when you make your own code, you don't ask me things like that. Remember, these are important comments. So they're not comments like multi-line or single-line comments. They're comments of documentation. I'll let you think about that one. And let's see. Types of house cat. I thought there was like one called a Persian or something else. Yeah, there. See, there's one called a Persian. All right. And Persian. Which inherits from cat. The values you fill out should make sense, by the way. So I suggest you slow down and really look at what you're doing. Especially if there are things like default values and stuff. All right. So Persian inherits from cat as well. These three items, I'll say Java files, Java files must also be accompanied by the appropriate comments. Both ordinary and Javadoc. So and please don't attempt to email me the files generated by Javadoc. It'll only get lost in the mail or not come to where my email file is. Section in the textbook will give detail on what Javadoc Comment is versus the multi-line should be. Like, I know there are tags that you can use. All right, so for those of you who feel like you need that, here, I'll toss you another one. Just to get you guys started. animal user is the user interface for animals, and let's just say for animal and its subclasses. Javadoc comments are missing. But can be added in using the details here. Of course, you have to comment on what you're doing. Can't give you a grade if you don't. That wouldn't be right. How do I know you made it up yourself? There should have been an Oracle. There was another Oracle tutorial. Let me just see. Here we go, annotations. You know what, let me not use that one. That might take you off course. There should have been another one. Remember, I extended from files. That's what I mean by inheritance. Cat inherits from animal. Let me just go back one. I'm sure there was like another document that I was reading that, and I've been reading these things for years on end. It's the same thing I just showed you not too long ago. It seems like it. Okay, so the one that I gave you, that's probably the definitive information for that. So like I said, you can find it. Right there. I'll leave that link in. The reason why I'm leaving that link in is because I generate the Javadoc for this right here. Animal user. One error. Let me just check to see what that would be. Invalid source release 15. Here, I'll show you what I'm actually referring to. Pretty sure I can just do this by hand. There shouldn't be a problem with that, but let me just go and change it. Okay, let's see. Properties. Use a different virtual machine for this one. Otherwise, I'll just have to momentarily call it quits, but, you know, try to show you through other means. and to get to that a bit later. Here, let me just go through the file system. I'll show you what I was talking about. Shouldn't be too tough. Let me go through my eWork, top down. Okay, so Javadoc. This is the other way to do it. Animaluser.java. All right, here I'll show you now. So as you can see now, I have a whole heap of different files. I'll toss them later. Now when I go to the index part, animal user, that's odd. Let me just go and see what happened on Eclipse. Reason why my comment isn't there. It came just before animal user, the class. All right, let's see what we have again. So basically, I put something in your document files, but I'm just trying to make sure that you guys are able to see it. So let me just make certain that it's clear for you guys to know where to look when you actually do open up the document file and see where I put the link to. Yeah, paragraph. And this is indeed what I did. Link URL and name. Okay, sorry about that. Here's what I should have done. Let's see if this thing shows up now. If it does, good, because then you'll have it to use as a guiding post. Once that works out, I'll have to send you on your merry way. Otherwise, I'll have to like find another way to like post it. That should be it. Yes. Oh, here, let me. All right, guys, questions, apparently.
I'm gonna be real. I don't really understand when to use Javadoc comments or how to use them to get them to show up right, or like when to use a regular comment or when to use a Javadoc comment.
Same here.
So I don't know where to put them, what's supposed to get them, what's not, or like what I'm supposed to write when I'm typing them.
All right, so the comments are making your own specifications. You put them before, actually that's part of the, well, one, it was part of the lesson, but also it's in the article. If I give it away too much, I'll just put it to you this way. They're supposed to immediately precede certain parts of your code, but I want you to read on it and try it out piece by piece. Take a look. This part here has an extra asterisk. That's what makes it not a multi-line comment, but a Javadoc comment. Now, if you do these in your actual IDE. The IDE for its own part is actually going to help take over and put things where they belong. So in that case, you'll actually have a huge help. If you try to do it by hand, then you may have difficulty. But if you don't do it by hand, if you do it with your IDE, it should actually be a major boost.
And when is this due?
Let's see. I'll aim for a week. It shouldn't be too tough.
Professor,
Yes.
so like as a Javadoc comment is just to like commenting and stuff. Wow, it's basically the same thing. We're just making like just notes on what we did.
Yeah, but you're also making it certain that that what the person finds is useful. And you're basically leaving behind details for other programmers as time goes on. So it's really, really important that you try it. Because, you know, it makes a huge difference in your programming. So that's why I think that it's not something you want to back out of necessarily. It's something you should definitely want to, you know, make your own personally. So that's why I am.
So basically, it's like accessing something like a specific part of the code or something like that.
No, it doesn't access the code. It documents the code. Documenting. Here.
Yeah, because I'm like very lost when you talked about Javadoc comments. So because I thought it just feels like it's just the same thing as just regular commenting.
No, it's not. No. Okay, so you see this thing right here. This is a Javadoc comment. Now, he says the resulting HTML from running that is shown below. So once you've run that particular comment, you'll notice that you have, well, like what I showed you, that whole index thing with, you know, the different functions there. Here, let's see. You're basically going to have something that looks like, let's see. Oh, here we go, example. So this is a normal single line. This is a multi-line. This is a Javadoc, the extra asterisk. Now, what it does is it actually has some functionality to it. So here you see that there's a link there, all right? And then also, this whole thing is immediately preceding this class part. All right, so that's the part that is, you know, being commented at that particular point in time. So now here you have standalone tags and inline tags. You don't really have to worry about those because your IDE will put them in for you. All right. So here's what you have once you, I won't say compile, but generate the Javadocs. All right. Take a look. Moving further down. I'm not going to talk about the Maven plugin.
Oh,
But
so
here's
it's
what you,
so
this
it's
right here is
yeah.
the outcome.
Oh, it's basically the one that you saw taught us in the first day.
Yeah.
So basically, it was just like a record it and put it into the document file, and then it'll send to that one, that HTML link.
It's not recording, it's documenting.
Yeah, I didn't say recording. I meant documenting. It's gonna be like
You're
sending
writing
over.
what you're doing as a comment, but you're formatting it so that it can become documentation as opposed to just comments in the code itself. So it generates documentation.
Can you show us like one of the examples? Like, can you click on it on yours?
Okay. Going back to day one, I believe it was, let's see, which one? Actually, even if it is not there on day one,
For example, like try using like.
Okay, here goes. So this one will work just fine. So this guy right here, let me go to project, generate Javadoc. All right, and so you'll see that I'm picking out this one file right here to generate Javadocs from, file IO character set EX. Once I finish, there shouldn't be an error there, don't worry. Here, let me go to file IO character set. I'll do it by the command line. So like that. And let's see, what did I call it? IO projects. No, I don't want it to be exhibit. I want it to be, let's see, majority of one. Okay, so I'm going to go into the one that says IO projects. All right, then I'm going to go to my sources. As you can see, the docs are already here. But now if I go to my sources, all right, in my sources, this is where my source files are. So I'm going to cd into com. All right. So here are my files. Now I'm going to do Javadoc on file IO character set. This guy right here. Okay, now when I go back into that part of my file system, my documentation has been generated for me. All right. And here is the documentation. So if you take a look at what happens when I click on this part here, I have a public file character set. Down here, you're going to see the following. Main is my entryway into the file IO project, which is exactly what I had put here in this other comment. Right up here, main is my entryway into the file IO project. Then you have these tags, parameter, args, command line arguments, and throws. When I take a look at that Javadoc comment, let me just go back to where it was. Here we go. So arguments, command line arguments at startup, that's my parameters part, throws, and this exception part. That's what it is. So they generate that for you on the fly.
Let's run project, build, and generate Javadoc.
Okay, so where was I? I was build ordinary Javadoc comments. comments are mandatory.
You said you're sending us the source files with with this like assignment thing.
They should already be up there.
It's okay in your Dropbox, right?
Yep, in the same folder. Do not skip the comments, anybody. Comments are mandatory. You need them to get credit. All right. Let's see, what's today? 25th. Yeah, and this isn't like January, so I have to look up on my calendar what a week from today would be. The 3rd. I'll give you to the 4th. So do March 4th. That's not to be quarters. Like that.
Copy.
Do March 4th, 2021. All right, give the enclosed Java source files, add Javadoc comments to all 3. Down here, note. Only send me your .java source files. Nothing else. If you try to send me anything else, the server is going to block it. Most email servers don't allow these things through.
You said you wanted them zipped last time, right?
Yep, thank you. So these things should be in a zip folder. Let me just go back out to the instructions. I did put the instructions there. Let me just, let's see, did I call this? This needs to be called assignment 1. All right. Now, here's how the instructions work. And I'll copy some of these over. The assignment and submission guidelines. I'll copy this over. That way you can't miss it. All right, so they're going to be in that general space where the assignments are. Here's how it reads. Here's how it works. All right, so the submission guidelines are as follows. Why does it say that right there? I should update this part. Let me just update it really quickly. This is 3115, not 115. All legitimate submissions must abide by the following instructions to receive any credit. Unless instructed otherwise, you must submit the Java source files only. The Java source files must be placed into a folder that is to be compressed or zipped. The folder to be zipped should include in its name, the name of the student, the class and section number, and the name of the project or assignment or exam being submitted. My own submission would read as follows. Here's my first and last name, the class that I am in, the section or time that it meets at, and the assignment that I am trying to get credit for, .zip. Or like this one down here. So the order, casing, spacing don't matter. The folder should be compressed as a .zip file. 7Z, RAR, and all others are disallowed. They're too difficult to open on other operating systems. With a zip file, I can open it on anything, including a mobile phone, so I can easily vouch for whatever you sent. Please fill out the subject field. If you want me to confirm that I received your submission in the body of the text, you should say so. All submissions are expected to be your own original work, unless I've granted any sort of, provision otherwise. This thing, let me just update it a little. I have something else in it, and in my other provisions, they're a bit more generous. So let me just get to my other file and I'll show you the difference. There is a difference. The other assignment submission guidelines. Let's see. All right. Let me just update this one, and then I'll explain the difference and why it's important. Okay. Let me just open this thing up. And let's see. So apart from that, here's what I said in another part. So please don't send them by way of Google Drive or Dropbox or OneDrive. That's horrible. Sometimes the links expire. Somebody tried that last semester and I told them that. And then they actually sent me one with the link that expires. But this is the important part. No late submission, no exceptions. That may sound like a bad thing, but it's actually better. All students must have the same due date. All right. You may submit a rough draft alongside a request for an extension by email, at which point I will decide whether to grant an extension to the entire class. Any such request must be made before the deadline and be accompanied by a rough draft of work completed thus far. How that works is as follows. Normally people try to send things in late and then, one person sends it 5 minutes after, another person says a half hour, then an hour, then the next day, then the following weekend. And then they all ask for partial credit. And then there's bickering over who did this and who did that. In this case, there's no late submissions. You can ask for an exception. If an exception is granted to the entire class, that means you can actually still get full credit. So in that case, I will take a look at how far people have gotten and then decide on any measures to push things back any farther. And that will be the new due date. And, you would get more time than what you probably would have gotten if you tried to cram it by the original deadline and send it after the deadline. But in that case, you get more time and you get full credit, right? So that's the method by which you want to abide by. Depending on how you use it, it could be your friend or your enemy. Make it your friend. Let's see. So that's pretty much that for the most part. And there was one part where I said the following. Let me take this part out.
Professor?
Yes.
Actually, no. After you're done with this, then I'll talk about it.
Okay. There we go. This was the other part. Please do not substitute details like the abbreviation for assignment. Basically, I'm searching my email for your assignment. So I have to search them, and Google won't understand a synonym. So the best way for you to make sure that does not happen is to send your assignments as, you know, specify. So ASSN1 will be assignment 1, ASSN2 will be assignment 2, that type of thing. The reason why, it's easier for the search engine to locate it. Yeah, I know that sounds awkward, but it really does work out that way. So, all right, somebody had a question or something. Go ahead.
So I was trying to. All right, so I did the Javadoc. I was trying to do the Javadoc as my own thing, right? So when I saw yours, you had a comment, right? But like on mine, I don't have any comments in the thing.
Okay, I will allow you to do a screen share. Hold on. Let me just stop my screen share and allow for your screen share.
Are we free to go right now?
Yeah, if you want, go ahead. Go ahead. Okay. This is just for like people who feel like they need to do a screen share. Go ahead. What do you see?
All right, so let me see here. Why is it right? So basically, this is my code, and I have my Javadoc dot comment. Right. This is what you talk about right here.
Wait, where'd you get that from?
Huh?
That's not. Oh boy, why'd you make a public abstract void sound?
Oh, this is something else. No, I was doing. No, see, this is my other thing. That's I was just talk about this one right now. This is another different type of code. So anyways, yeah. It's something separate from outside the class.
Okay, let's just get to like the basic stuff then.
Right here. All right, so this is Javadoc Comment, right?
Okay.
All right, so no, when I say I'm opening it up as this. Right. All right, so I get here. And I don't see it right here, like the comments.
I see it. Scroll up.
Oh,
right there.
This one?
Yeah, that's where you wrote it. Author, and then the other part.
Oh, I see.
Okay.
I guess it was different for everyone else, right?
Yeah, you may not want to like jump ahead and stuff if you want to like show me where there are hiccups. We didn't get into abstract classes or interfaces today, but that's to come next time.
Yeah, it's something else I'm just trying to practice on, that's why.
All right, have a good night, Connor. All right, other people have their hands up. What's going on? People with your hands up. How can I help you?